Welcome back, everybody. So we're still in 2.2 as basic differentiation rules. So we're going to start looking at some examples now, both of using those derivative rules that we derived previously, so the power rule, the derivative of cosine as well as sine, and then looking at some application style questions, which looks like we're going to start with here. So we've got a ball that's thrown down from the top of a building with an initial velocity of negative 22 feet per second. So I'll just note velocity has sign because velocity is a vector and it describes the direction and speed together. So the speed is 22 feet per second. The direction is down, which we would use a negative sign for. And also, since we're using feet, that's going to indicate that our position function is going to use negative 16 instead of negative 4.9 for that gravitational constant times 1/2. So we'll have negative 16t squared minus 22t, and our building is 220 feet. So that'll be our general equation. So we want to figure out what is the velocity after 3 seconds and what is the velocity after falling 108 feet. All right, so we got two different questions here. Velocity after 3 seconds, well, we just need to find the velocity function, which is the derivative of s. So using our power rule, we get negative 32t minus 22. So then s prime of 3 is going to equal negative 32 times 3 minus 22. So that is negative 96 minus 22. So I believe that is negative 100 and 18. And note feet per second. Be sure to indicate units of measure. All right, so that's the first part. So then for the second part, we want the velocity after falling 108 feet. So if it's fallen 108 feet, that means our position is 220 minus 108, which is 112. So s of t equals negative 16t squared minus 22t plus 220 equals 112 is going to be what we want to solve. So we can subtract 112 over and we'll get plus 108. And then now we can, try to figure out what the velocity is after it's fallen this far, but we need to figure out what is the time t where this is true. So let's go ahead and divide both sides by 2, it looks like. So we're going to get negative 8t squared. Actually, let's divide by negative 2, just so we get a positive leading coefficient. So we get 8t squared plus 11t minus 54. Okay, so you can try and work through and factor this if you want to, but just as a reminder, you can also use the quadratic formula. So t is going to equal negative 11 plus or minus the square root b squared minus 4ac. So that's going to be 11 squared. That's going to be a negative 54. So we'll just make that a plus. All over 2a. So let's see, 4 times 8 times 54. Let's go ahead and calculate that real fast. plus 11 squared is 121, which is 1849. So what is the square root of 1849? 43. All right, so it does factor. All right, so it's going to equal negative 11 plus or minus 43 all over 16. So obviously t is not going to be negative, so we will add 43 to 11, and we'll get 32 over 16, which is 2 seconds. All right. So that means we need to find s prime of 2, which is going to be negative 32 times 2 minus 22 from our previous work. And so we get negative 64, so negative 96 feet per second. So again, using quadratic functions, we're going to use definitely the quadratic formula if we need to. So again, this factors as well. So you could factor it if you needed to. But also vertex, right? So we might want to find the vertex, the maximum height of our curve if it is a quadratic that is opening downward, or the minimum if it's opening upward. So we'll get into that a little bit later in the course. In chapter 3 we'll focus on minima and maxima, but they will pop up from time to time in this chapter as well. All right, so that completes question 1. For question 2, we've got a table. So we got f and g are two differentiable functions, but we have some limited information. So here we're actually just going to go through and use those properties of derivatives that we started with. So just note on the notation, if we have f plus g prime of 3, that is the same as f prime of 3 plus g prime of 3. Right, so the derivative of the sum is the same as the sum of the individual derivatives. So we can go to our table here. So it looks like f prime of 3 is negative 1 and g prime of 3 is 9. So negative 1 plus 9, which is 8. Okay, and then now we're going to define a new function h that is a combination of f and g. So we want to find h prime of negative 4, so we'll start with h prime of x, which is just going to be 7f prime minus 3g prime. And so we're going to get at 4, negative 4. 7 times f prime of negative 4 is 10, minus 3 times g prime of negative 4, which is negative 15. So we're going to get 70 plus 45, which is 115. All right. So then we've got q of x, which is a combination of a quadratic function and g. So we'll do q prime of x, which is going to be 2 pi over 3x using the power rule, plus pi g prime of x. So q prime of 1 is just going to be 2 pi over 3 plus pi times g prime of 1, which is 2. So we got 2 pi over 3 plus 2 pi, which over 3 is going to be 6 pi over 3. So our answer will be 8 pi over 3. And then last, part D here, we've got r of x. We want to find r of negative 4, so we just need to substitute. We don't have to find any derivatives. So using what we know about negative 4, so f prime of negative 4 is 10. G prime of negative 4 is negative 15. Minus 2 times f of negative 4, which is 7. Plus 5 over g of negative 4 is negative 5. So we're going to get negative 150 minus 14 minus 1, which is negative 165. So just some evaluations using a table. And last problem on this page is going to involve what we call the normal line. So a line normal to a curve at a given point is the line that is perpendicular to the tangent line. So if we have a curve, and that curve has some tangent line at a point, the normal line is the line through that same point that's going to be perpendicular. And the normal line has applications in physics for three-dimensional spaces. So if we want to find the orthogonal vector to a curve that's tangent at a point, that would be the orthonormal line. And so this line normal is just a two-dimensional representation of that. So essentially, we just need to find the equation of the tangent line and then take the opposite reciprocal slope. So find the equation of the tangent line to the curve. Y equals -1/16 x squared when x is 8, and then find the normal line. So we're going to do both here. So we'll start with the fact that y prime, let me zoom in a bit here. So y prime is going to be 2 times 1/16, so 1/8 times x. And so y prime of 8 is going to equal 1. Yay! Which means that our normal perpendicular slope is -1/1. So just the opposite reciprocal, but it stays just the same number, just changing sign. And when x is 8, we'll note y of 8 is going to be 1/16 times 64, which is 4. Okay, so then we've got our tangent line and our normal line. So tangent is going to be y minus 4 equals, the slope is 1 times x minus 8, so you could just put x minus 8 if you wanted to. And the normal line is going to be y minus 4 equals -1 times x minus 8. And again, you can always leave your linear equations in point-slope form. So you can distribute if you want to, but you don't have to. Okay. So then down below here, we've got kind of a longer problem involving velocity and distance. And then we've got a trig equation, and then we've got some more parabola work. So I think we'll do these next 3 problems on the next video. So again, once you've completed these, if you do have questions, send me an email or come by the office hours. Otherwise, until I see you next time.